चिल्ड्रेन, तो हम लोग फ्रिक्शन इस बिट का कंसेप्ट समझ लिए हैं और उसमें बहुत से प्रॉब्लम्स भी सॉल्व किया है। ब्लॉक ओवर ब्लॉक, अभी एक सरफेस पर, रफ सरफेस के ऊपर एक ब्लॉक रखा है, ब्लॉक के ऊपर दूसरा ब्लॉक रखा है। अब इसमें किस तरह का मोशन होगा जब एक एफ फोर्स इज अप्लाइड, राइट। इसके ऊपर भी हमने एक वीडियो बनाया है और उस पर भी कंसेप्ट समझा दिया है। तो आज उसी चीज को हम एक डिफरेंट फॉर्म में एक फार्मूला एस्टेब्लिश करेंगे, जिससे कि उस फार्मूले के माध्यम से किसी भी तरह का प्रॉब्लम व्हेन फोर्स इज एक्टिंग ऑन दिस ब्लॉक कैन बी फाउंड आउट। मैक्सिमम फोर्स हम कंफर्टेबली और इजिली निकाल सकते हैं जब ये दोनों ब्लॉक साथ में मूव कर रहे हैं। इस तरह के प्रॉब्लम में कोई भी प्रॉब्लम अगर आता है तो फोर्स जो लगाया गया है इसके ऊपर, उससे क्या दोनों ब्लॉक साथ मूव करेंगे या फिर दोनों के बीच में एक रिलेटिव मोशन रहेगा। इसके लिए फॉर मैक्सिमम फोर्स विथ विच बोथ द ब्लॉक्स विल मूव टुगेदर, उसमें एक मिनिमम फोर्स रहेगा। मिनिमम से आगे बढ़ेंगे तो दोनों ब्लॉक साथ में चलेंगे, और एक मैक्सिमम फोर्स आएगा कि उससे बियॉन्ड अगर फोर्स हो गया तो ये दोनों साथ में नहीं चलेंगे। तो एक फार्मूला हम स्टेब्लिश करेंगे जिसको यूज करके हम हर सिचुएशन में डिफरेंट वैल्यूज ऑफ कोएफिशिएंट ऑफ फ्रिक्शन हम मैक्सिमम फोर्स निकाल सकते हैं। देखिए अभी क्या है कि इस सरफेस पर एक ब्लॉक रखा है, ब्लॉक के ऊपर दूसरा ब्लॉक रखा है। इन दोनों ब्लॉक्स के बीच में कोएफिशिएंट ऑफ फ्रिक्शन जो है दैट इज μ1, राइट, एंड इस पर μ2 है। अब इनफैक्ट इट इज स्टैटिक फ्रिक्शन इज गिवन, राइट। अब सिर्फ एक ही फ्रिक्शन दिया है, तो जब रिलेटिव मोशन होगा तो वहां तो काइनेटिक फ्रिक्शन लगेगा, तो कोएफिशिएंट ऑफ फ्रिक्शन जो है काइनेटिक कोएफिशिएंट ऑफ फ्रिक्शन रहेगा। लेकिन एक ही दिया है तो वही हम दोनों जगह यूज करेंगे, ठीक है, अच्छी बात है। अब देखिए इस पर एक फोर्स लगा तो हमको वो मैक्सिमम फोर्स निकालना है जबकि दोनों ब्लॉक साथ में मूव करेंगे। दैट मैक्सिमम फोर्स as long as both the blocks are moving together. So we want F max, right, when both the blocks move together. ये चीज अपने को निकालना है। मैक्सिमम फोर्स F max when both the blocks move together, क्योंकि उससे ज्यादा होगा तो उसमें रिलेटिव मोशन आ जाएगा ना। इसके लिए हम स्टेप बाय स्टेप, हमारा अगर प्रीवियस वीडियो देखेंगे तो हमने डिफरेंट स्टेप्स बताए कैसे उसको मैक्सिमम फोर्स निकालना है। पहला स्टेप ये है कि हम दोनों कॉन्टैक्ट सरफेसेस के ऊपर लिमिटिंग फ्रिक्शन निकालेंगे, ठीक है। सो स्टेप नंबर 1, तो लिमिटिंग फ्रिक्शन बिटवीन A and B and limiting friction between B and, suppose this surface is C, between B and C, right. Now mass of this block is m1, so m1g is acting downward, so normal reaction, that is n1, is acting on this mass. m2 acting downward along with m1g, so total weight of both the blocks will act on this surface, that is m1 plus m2g, and accordingly normal reaction n2 will be acting on the mass B, A and B. अच्छी बात है। So we will find the limiting friction between A and B. So I will write like this: limiting friction between A and B. We will denote F limiting, that is AB. I will write like this: limiting friction between A and B, that is μ1 into n1, that is normal reaction at this surface. Now, force is applied on this. This mass will have tendency to move in this direction. So it means frictional force between these two surfaces will act in this direction. Right? Similarly, since it is trying to move in this direction, so between B and C also force will act in opposite direction. And since between these two surfaces frictional force acting on B is in this direction, so on this it will be acting in this direction, that is FLAB here, I here FLAB, I here FLBC. Getting? This is the limiting friction between B and C. This is the limiting friction between A and B. This force is acting on B. This force is acting on A. This is the maximum frictional force between A and B. So FLAB is mu1 N1. And what is N1? So here N1, that is equal to M1G. Downward force M1G, downward reaction, that is N1. Both will be equal because there is no vertical motion in this. So therefore FLAB is equal to mu1 N1. So N1 is M1G. So mu1 M1G. Similarly, we will find FLBC, and limiting friction between B and C, that is FLBC, is equal to how much? Mu2 N2, that is mu2 N2. Normal reaction on B. So this is, what is N2? N2 is M1 plus M2G. So I will write N2 is equal to M1 plus M2G. So that is mu2 M1 plus M2G. So two things we got, that is maximum friction between the two contact surfaces A and B and B, C. Now second step is we have to find that block on which only frictional force is acting. See, on this F external force is acting, here only frictional force is acting. So on this we will make FBD of A. So if I am making FBD of A, that is M1, so only frictional force is acting in this direction, that is FLAB, right? Mass is M1, so we can find, and since it is the maximum force, so we can find the maximum acceleration, maximum possible acceleration of the block A. Therefore, maximum possible acceleration of A is equal to A, that is equal to FLAB upon M1. Mass is M1. Therefore, A is equal to FLAB is how much? Mu1 M1G. That is mu1 M1G upon M1. So M1 will go, we will get mu1G. Therefore, maximum possible acceleration of A is mu1G. Right? A cannot have acceleration more than A. That is mu1G. Now, we will talk about the block B. Now, force is applied. So, as long as both the blocks are moving together, so maximum acceleration of B should be equal to mu1G. That is the maximum acceleration of A. So, you will find the net force acting on B. Now, this acceleration will be in this direction, moving together, both are moving together. Now, this is the block B. that is M2. Here F force is acting, two forces on this, that is FL AB is acting and FL BC is acting. So F net will be how much? So F net is equal to F minus FLAB plus FLBC. That is the net force acting on mass M2. That is equal to how much? F minus FLAB, that is mu1 m1g, mu1 m1g plus FLBC, that is mu2 m1 plus m2g, that is mu2 m1 plus m2g. So this is the net force acting on the block B, and since both are moving together, so acceleration in B will be how much? F net divided by m2. Therefore acceleration of the block B, F net is this, mass is m2, therefore the acceleration of mass B is equal to F net by m2. So that is equal to F net is F minus mu1 m1g plus mu2 m1 plus m2g divided by m2. This is the acceleration of B. If A and B have to move together with maximum acceleration, then maximum acceleration should be equal to mu1g only. It cannot be beyond that, because A will be having maximum acceleration of mu1g. Therefore F minus mu1 m1g plus mu2 m1 plus m2g upon m2, that is equal to mu1 g, that is equal to A. From this we will get F is equal to mu1 m2g plus mu1 m1g plus mu2 m1 plus m2g. We can write like this, multiply this with m2 that I have written, transfer whole quantity on right hand side, you will get mu1 m1g plus this. From these two we can take mu1g common, therefore we can write m1 plus m2, this is mu1 g plus mu2 m1 plus m2g, and from this we can take m1 plus m2g common, therefore further we can write, therefore F is equal to mu1 plus mu2 m1 plus m2g. This is the maximum force which will take these two masses together with maximum acceleration of mu1 g. So we can say this force is the maximum force. This is what, but that is why it can be written F max. So finally, what did we get? See, if certain coefficient of frictions are there from these two surfaces in contact, mu1 and mu2, then the maximum force, when masses are m1 and m2, then maximum force till both the blocks move together is this. So we can consider this as a formula, right? Various cases, various situations, different values of mu1, mu2 will be there, and in that case formula will go on changing. So if you remember this, The only thing, very important thing you will have to remember that in this case, force is acting on the lower block and that force is maximum force, right? So finally we got that formula for maximum force. By applying that much force, maximum force, both the blocks will move together. The same formula can be established in different way also, considering the system of these two blocks. See how. Now, we have got maximum acceleration of this as mu1g. This we have got. Means the maximum force by which both the blocks will move together can have maximum this much acceleration, right? If we consider this as both the blocks as system, in that case total mass will be m1 plus m2 and we will consider the only external forces which will create acceleration in this system. All internal forces neutralize or cancel each other. Like here, frictional force acting along this surface, that is mu L AB. On this force is acting along this surface itself, FL AB. So it means these two forces will neutralize when we consider these two blocks as system. ध्यान में रखो, ये हमने पहले बताया हुआ है. अगर सिस्टम कंसीडर करते हैं तो वी डोंट कंसीडर द इंटरनल फोर्सेस, दे डोंट क्रिएट एनी काइंड ऑफ acceleration in the system. Only external forces cause acceleration in the system. M1 and M2 is considered to be a system. It means these internal forces, two frictional forces are at this surface, contact surface, won't cause any kind of acceleration. Now, this force is the external force and this FLBC is also external force because it is at the boundary of the system. Boundary is this, right? Beyond boundary this is acting and it is also acting at the boundary. So these are the internal forces, these two are the external forces. So external forces will cause the acceleration in the system. So how much acceleration can be created by these external forces? So net external force, method 2 I will say, method 2 by which we will find the F max by considering the system. So net force, this is external force, this is also external force, these forces are the internal forces, they will get cancelled out. So net F net external force, this is an object, this whole object will be moving in this direction if this is more than this. So F net is F minus FLBC. This is the F net. For what? For the system. Considering blocks A and B as system, in which external forces are F and FLBC. These two are external forces and these two are internal forces. So F net, F minus this object, system is moving in this direction, that is F minus FBC. How much it is? M1 plus M2 G into mu2, right? So that is mu2 M1 plus M2 G. That is the F net. This much force is acting on the system. Therefore, acceleration A system, suppose AS I write. A is the acceleration of the system. That is F net upon whole system I have taken, that is M1 plus M2 बात समझ में आ रही है? ध्यान दो बच्चों, ध्यान से देखोगे तो समझ में आएगा। सिस्टम पार्ट हमने पहले समझा दिया है। इस सिस्टम की बात करेंगे तो टोटल मास लेना पड़ेगा, मास ऑफ द सिस्टम। मास ऑफ द सिस्टम इज दिस मास प्लस दिस मास, टोटल मास से डिवाइड किया। एफ नेट, इस सिस्टम पर नेट फोर्स कितना है, दिस माइनस दिस, एफ नेट ही आ गया। उसमें टोटल मास से डिवाइड कर देंगे तो उसमें सिस्टम का एक्सेलरेशन आ जाएगा। ठीक है, अच्छा, एफ नेट इज व्हाट, दैट इज एफ माइनस म्यू टू m1 प्लस m2 g अपॉन m1 प्लस m2। अब इसका मतलब क्या हो गया कि सिस्टम का एक्सेलरेशन इतना है, मैक्सिमम एक्सेलरेशन इसका हमने निकाला है इतना। तो सिस्टम में दोनों साथ चलना है तो मैक्सिमम एक्सेलरेशन कितना हो सकता है, इतना हो सकता है। Acceleration cannot go beyond this because this is the maximum acceleration of A. So this acceleration will be either less than this or equal to this according to condition. So I will write, therefore AS, that is acceleration of the system, is less or equal to A. Is it clear? Because maximum acceleration of this is A, acceleration of the system is this, so maximum acceleration which the system can have is this much. So this is F minus, AS is F minus mu 2 m1 plus m2g upon m1 plus m2 less or equal to mu 1. Is it clear? Okay. Further simplification. Directly I will write F is less or equal to mu 1 m1 plus m2g plus mu 2 m1 plus m2g. Multiply this by mu 1g and transfer this quantity on right hand side, so we will get this. So here F is less or equal to this. If I have to get maximum force, then F will be equal to whole quantity. Maximum. Maximum how much? F is equal to this. Otherwise, F will be less than this. So therefore, F max. F max means it will be equal to this one. Otherwise, it will be less than this. So from these two, we can take m1 plus m2g common. So we'll get mu1 plus mu2 m1 plus m2g. Here also we got the same result we got over here. It means second method is considering this as system, we got the same result. So children, you should remember one thing. ये फार्मूला आप कहीं भी यूज कर सकते हैं, लेकिन कंडीशन ये है कि ये फोर्स जो है लोअर ब्लॉक पर लग रहा है। कोएफिशिएंट ऑफ कुछ फ्रिक्शन कुछ भी रहने दो, सपोज अगर इसका कोएफिशिएंट ऑफ फ्रिक्शन 0 हो गया तो यू कैन पुट म्यू टू 0। सो जो फार्मूला बन जाएगा, दैट इज द मैक्सिमम फोर्स व्हेन बोथ द ब्लॉक्स आर मूविंग टुगेदर, दैट इज mu1 m1 प्लस m2g। जैसा हमने पिछला वीडियो देखोगे तो हमने एक क्वेश्चन सॉल्व किया था, mu2 इज 0, उस केस में कैसा सिचुएशन आया था, राइट। सो कुछ न्यूमेरिकल प्रॉब्लम्स बनाते हैं with the same formula, with the same concept, then understanding will be much better, right? So this is the question. It is 20 kg block. Over this 10 kg block is kept. Between these surfaces B and C, coefficient of friction mu2 is 0. In between there is friction mu1, that is 0.6. Then what is required? Find the maximum force, right, till both the blocks move together. दोनों ब्लॉक जब साथ में मूव करते हैं तो मैक्सिमम फोर्स कितना हो सकता है कि बियॉन्ड दैट दे विल नॉट बी मूविंग टुगेदर। यह फार्मूला हमने उसके लिए एस्टेब्लिश किया है। ध्यान देना इसमें, लोअर ब्लॉक पर जब फोर्स लग रहा है तभी वो फार्मूला यूज कर सकेंगे। अपर ब्लॉक पर फोर्स लगेगा तो नया फार्मूला एस्टेब्लिश होगा, दैट आई विल टेल यू लेटर। ये सिचुएशन कैसा है कि लोअर ब्लॉक के ऊपर जो फोर्स लग रहा है वो मैक्सिमम फोर्स कितना होगा, उसके लिए वो फार्मूला है, राइट? रिमेंबर दैट फार्मूला। μ2 is the lower, μ1 is the upper. Now F max is required, so F max, that is equal to how much? μ1 plus μ2 m1 plus m2g. Put the values. μ1 is 0.6 plus 0, m1 plus m2 10 plus 20 into 10. Take the g is equal to 10 meters per second square. So how much it is? 0.6 into 10 into 30. So that is 180 Newton. That is F max. F max is 180 Newton, right? More than 180 Newton, both of these blocks will not move together. अब ये हमने फार्मूले से निकाला। By conventional method, find the maximum force. अगर कन्वेंशनल मेथड से अपने को मैक्सिमम फोर्स निकालना है जब both the blocks are moving together, so how will we do? First we will find the maximum friction between these two blocks and maximum friction between these two blocks. Since coefficient of friction is 0, here FLBC that is equal to 0. यहां पर निकालना है तो हम क्या बोलेंगे? FLAB, backward force, here FLAB on this. Weight at 10G is acting, normal N1 is acting, here total weight 30G, normal is N2, right? So we will find FLAB first. FLAB, limiting friction between A and B, that is μ1 into N1, μ1 N1, that is μ1 into 10G, 10G. So μ1 is 0.6, that is 0.6 into 10 into 10, that is 60 Newton, right? 60 Newton maximum force will act on A. So what will be the acceleration of A? So that is, suppose maximum acceleration is moving together, then acceleration is A. So maximum acceleration of A is how much? That is FLAB upon 10. So that is 60 upon 10, that is 6 meters per second square. Means maximum acceleration which A can take is 6 meters per second square. The block B, when it is moving, so maximum acceleration the block B can have a 6 meter per second square. At that time force will be the maximum one and both will be moving together. Beyond that force they will not be moving together. So FBD of B, if you make, that is B, mass is 20 kg, F is acting here, that is FLAB. FLAB is acting, that is how much? That is 60 Newton on this side. Along this force is 0. FLBC is 0. So net force, that is F net, that is equal to F minus 60, right? Therefore acceleration will be how much? Suppose AB, that is F minus 60 upon 20, and this acceleration maximum it should be maximum, that is how much? That is 6 meter per second square. But AB is equal to A, therefore F minus 60 upon 20, that is equal to 6. Therefore F minus 60 is equal to 120, Therefore, F is equal to 180 Newton. See, by conventional method also we got the same result. But using the formula, it is 4 lines we could do. So it is always better to remember the formula. Wherever required, you can use this formula also. But concept should be made very well clear that in this case, force is acting on the lower block. Okay. So we will take some more numerical problems and things will be more clear. See, in this case, since friction between these two surfaces is 0, right? There is no friction between these two. Means there is no opposition for the motion. If little bit force is applied, the whole system will start moving. Why? Because these two blocks, there is no friction between these two, so there is no opposition for the motion of the block B. A bit force is applied, it will start moving. It means minimum force required to move both the blocks will be 0 plus something, little bit 0. So, and this is the maximum force when both the blocks are moving together. It means as long as this force is lying between 0 and 180 implies both the blocks move together. Getting what? 180 Newton is the maximum force when both the blocks are moving together, and minimum force required to move both the blocks together is 0 plus something, a bit, slight push, both the blocks will move, because friction between these two surfaces, this surface and this surface coefficient of friction is 0, so no opposition is there for B. Slight force will make the mass B to move, and since friction is lying between these two, so both will be moving together till the force is 180 Newton, right? So 0 and in between whatever force is there, that will make both the blocks to move together. Clear? Now, another question based on this concept itself. Suppose F is given. F is equal to, suppose, 140 Newton. If force is 140 Newton, so 140 lies between 0 to 180. It means when F is 140, both the blocks will move together. Then what will be the acceleration? Then acceleration is what? This is the question. In this case, what happens? If maximum force when we are taking, so in between these two, limiting friction is acting. If force is less than this, the friction automatically gets adjusted. Means there will be static friction acting, right? But limiting friction won't be there. In that case, it won't be limiting. This will be how much? In that case, it is Fs, right? And this friction itself, it is 0, there is no problem. Here also it won't be limiting friction, it will be F static friction. पास समझ आ रही है? जब हमने मैक्सिमम फोर्स निकालने की जरूरत समझी, उसमें हमने मैक्सिमम फ्रिक्शनल फोर्स दिया यहाँ पर. Now this force is less than the maximum frictional force. Automatically static friction will get adjusted and both will be moving together, but the frictional force won't be the limiting friction, it will be static friction Fs something, right? And Fs will act on this and Fs will act on this also. So this Fs will create some acceleration in this. So we can write Fs is equal to, in this case, right, acceleration is A, mass is 10. So that is 10A in case of block A. And for block B, backward force is Fs, forward force is F. So F minus Fs, that is equal to 20A. So we can find the value of A. Value of F is given, that is 140, minus Fs is 10A, that is equal to 20A. Therefore 30A is equal to 140. Therefore A is equal to 140 upon 30, that is 14 upon 3. So A is equal to 14 upon 3 meters per second square. If 140 Newton force is applied on the lower block, then the combined acceleration, both will be moving together with the acceleration of 14 by 3. So children, I told you the concept today. I had derived one formula, which is the universal formula, you can say. When the force is acting on the lower block, you can use it wherever this kind of situation arises and its application. And now I have taken one problem also. Some more problems I will take using the formula or by conventional method, both are told to you. So आप दोनों में से कोई भी यूज कर सकते हो. हम एडवाइस करेंगे, एक ही चीज आपको ध्यान में रखनी पड़ेगी कि जब लोअर ब्लॉक के ऊपर फोर्स लगता है तभी ये फार्मूला यूजफुल है. जब अपर ब्लॉक के ऊपर फोर्स लगता है तो फार्मूला डिफरेंट होगा, वो भी हम स्टैब्लिश करेंगे. लेकिन इसके ऊपर कुछ प्रॉब्लम सॉल्व कर लेंगे वेरियस एस्पेक्ट में. देन वी विल गो फॉर द फोर्स अप्लाइड ऑन द अपर ब्लॉक. और उस समय सिचुएशन कैसा रहेगा, दैट टू आई विल टेल यू. सो आई विल मीट यू अगेन. Till then, all the best. Take care of you.